In this example here, you can see we're dividing a mixed number by another fraction. And what I recommend first is we're going to rewrite this so that it is an improper fraction. So I drew 3 rectangles, and I'm going to, so this rectangle is going to be one whole amount. And then we need to shade in. So I have 2 whole amounts, and then we need 3/4 more, which means this third one, I'm going to split it up into 4 sections, and I'm going to shade in 3 out of 4. So this represents 2 3/4. So I have 3/4 shaded in here. Now to go to an improper fraction, all you gotta do is split this up the same way this is split up into 4 parts. So I'll do the same here, and you can see here we have 4 out of 4 shaded in, 4 out of 4 shaded in, and then 3 out of 4 shaded in. And when you combine these amounts, you get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 fourths. So 2 3/4 is the same exact thing as 11 fourths. And I'm going to bring down the divided by 1/8. And now we can go to the next step, which is to keep that the same. This changes to multiplication. And then 1/8, you do the reciprocal. Flip the fraction, switch the 2 places. And that's the reciprocal. And then now we can actually go ahead and multiply these fractions. So these are equivalent to each other. And if you don't know why it goes from division to multiplication, make sure you watch the video included in this section of the worksheet where I go over that in more details, and I'll show you an illustration of what's going on behind that. And now what you do is you check for any common factors between like this number and this number, or this number and this number. Same thing over here, this number here and this number here. And I can see these two have a common factor. And the greatest common factor would actually be 4. So that means I could divide this number by 4, and I could divide this number by 4 also, which gives me 11 over 1 times 2 over 1, right? These stayed the same. The 11 stayed the same. The 1 stayed the same. It was just these two that simplified. So I can highlight so you can see that's the only numbers that we fixed, that we simplified. And now I can actually go ahead and multiply. So since we took care of simplification here, we found the greatest common factor between the numerator and denominators. We can see that my final answer when I multiply will already be simplified. So this will be 22 over 1 times 1 is 1. And when you multiply or divide this out, you actually just get 22 as your final answer. And then also, I just want to point out that if I did not go ahead and divide both of these by 4, so let me just rewrite it. 11 over 4 times 8 over 1. If you just multiply directly, 88 over 4, right? Multiply. Then you'd have to actually find the greatest common factor in the end. But if you notice when you do it here, finding the greatest common factor, it's easier because the numbers are smaller. But then when the numbers get bigger, it might not be so obvious as to what the greatest common factor is, which is where knowing your multiplication facts helps out. But in this case, you can see if I did divide this, I would actually just get 22 as my final answer. But if you didn't notice that, then you're saying, okay, let me find out the greatest common factor. And if I were to find the greatest common factor for these two numbers, I would see that it would actually be 4, and I would get 22 over 1. And then when you simplify that, 22 over 1, it just becomes 22. So just another way you could do the same exact thing. But I recommend doing it here first, because when you simplify first, before you multiply, numbers stay smaller. It's a lot more obvious as to figuring out what the greatest common factors are, versus if you actually multiply them out first, numbers get bigger and it's less obvious.